All right, so today we will start section 4.5, where we'll be talking about the graphs of sine and cosine functions. I think we already know that that those are the primary trigonometric functions out of all the six, because if you know sine and cosine, you'll be able to know all of the others four functions. And these are periodic functions. We have also seen that that how the periodicity come into the picture, because all the values are repeated periodically, and you see all of those things here again, since you'll be looking at the graphs of sine and cosine. Now let's look at the sine function first. Before we start, make sure we realize that this is just a regular function, right? Y equal to f of x, right? Just like the y equal to f of x function. So here, so you will be able to plot just like the regular graph, as long as you have some points for x and some points for y. And think about the y equal to f of x. What we did when we plotted, we needed to identify first which one is the independent variable and which one is the dependent variable here. So same is here. X is your dependent variable. The independent variable, and y is the dependent variable. So based on the x, because your function will be taking x as an input and y will be the output. Now what will be the x? X will be the angle, right? For those, we'll be finding the sine. Okay, here all the inputs are given in radian, but we understand that radian and degree are same to us. So all the inputs are given in the radian, and as you see that, let's say in general, how we draw the graph. In general, we first identify a couple of points for x, and then based on those points, we find the y's, right? And then we know the x and y's, and we can plot the graph. That's the basic steps we do for any graph, and this is nothing different here. You see, we just try to find those points. So the first one is 0 degree, right? Next one is pi by 6 is 30 degree, right? Because pi is 180. So, pi is equivalent to 180. So the 180 by 6, which is 30 degrees. So the next one is 60. So you see all these points here. These are the intervals you can pick any points, but in general we pick some points which are suitable and most commonly used. So this is like 30, 60, 90, and then 120 and 180, and that's how we took all the points. Okay, and for those points we evaluated the y's. But if you look at the
y carefully, look at this. All the values are repeated. Do you see that? Here, everything is repeated after here. After 180, all the values are repeated, but except they are negative right now. Even after 360, we don't see it after 360, because after 360, everything will be starting over. Okay? Because this is from 0 all the way to 180. All the values, look at the next values from 180 to 360. They are exactly same, except they are negative because they are in this side. Okay? But after 180, it will be periodic. After 360, all the values will be repeated again. For an example, value of 370 will be similar to sine 10. Or value of, let's say, 390 will be exactly like sine 30. You just subtract 360, it will be same. Because they are exactly the same angle, because after 360 you are basically going to the same same quadrant, and you are producing the same kind of angles. And if you look at here, we wanted to show you a little bit bigger picture that what happens basically after, let's say here up to 180, and then here up to 360. After 360, you see everything is repeated. It's just like the same thing, repeated. We've seen this is a periodic function, and from 0 to 360, this is called one cycle. And again, because one cycle means you can start the cycle from any point, And when you complete the cycle, it means that after that point, everything will be repeated again.
Because look at this. If you start from here, your cycle will stop at, if you start your cycle at 0 degree, it stops at 360, because after 360, same thing is repeated again. Do you see that? You can start your cycle anywhere, but formally people assume that, okay, this is the cycle starts, here is one cycle, but if you start the cycle here, what happens? Where the cycle will end? Let's say you start your cycle at 90 degree, okay? Your cycle will stop here. Because look at this. After this point, everything is repeated again, okay? So, you know, that's how you can understand how, how a complete cycle will look like, okay? After the complete cycle, everything will be repeated again and again and again. So, in general, we assume that the cycle is starting from 0 degree. That's a generic convention, but you know, you don't have to do that. So anytime you start cycle from any point, and you will go all the way when the points are not repeated. And after some point, you'll see that everything is starting over. That means your cycle is stopped there. Okay. So this will happen to all the trigonometric functions: sine, cosine, cosec, tangent, cotangent, everything, okay? But since we know that all the trigonometric functions are depending on one on other, so the basic ones are sine and cosine, so this section will be only talking about the sine and cosine, because we know that as long as we understand the sine and cosine, we can understand the rest. Now, graphing variations. Now, what do you mean by variations? Before we start here, remember the functions, we know that how the functions can be plotted based on different variations like horizontal movement, remember, vertical shifting, remember those kind of shiftings. Now how those shiftings can also be applied here, nothing is different here, still we are talking about the same thing. We'll be talking about the horizontal shifting, vertical shifting, you know, all of those things, and we'll show you that how those variations also is applied to this function, because this is nothing other than just a regular function. The only difference is this is a trigonometric functions, this is a periodic functions, the values are being repeated. Now, so in the bottom one, you see that, for an example, the blue graph is the original y equal to sine x graph. But look at the red one. What happened to the red one? That is still a sine graph. I'm saying the sinusoidal graph. But what happens? That's 2 times sine x. Now what happens when you multiply the function by 2? Do you recall it? Remember? What happens? It's being stretched, right? That's exactly what happened. Look at this. It's something like somebody is stretching the circle. But still the period is same. Do you see the period? What is the period here? It's 2 pi, right? Period means to complete the whole cycle, how much angle you need. To complete the whole cycle, you have to go all the way to 2 pi. So it's still that is 2 pi, but it looks like somebody is stretching because of this. And it's the same thing. Remember, if you multiply with some whole number, if the whole number means whole number and the number is more than 1, then your function is stretched. And the same thing is happening here. So you will see all those things here. I'm not going over this, but this is the same thing like this one. What happens? How to draw the graph? That's the basic. Some of the so what we are going to do is when we draw the graph, we'll pick some points. Especially we'll pick 5. Okay, 5 points for x. Very common 5 points: 0 degree, 70, 360.
It's basically we are starting from 0 and taking interval of 90 degrees all the way to 360. Look at this. 0, 90, 180, 270, 360. So to draw any sine graph, even it is true for cos as well, what we do is we just take all those 5 value of x first, and you know, using the calculator or you know anything, you can just find the y for all of those value, and once you have x and y, you will know the coordinates, right? You just know the x and y, you will know all the 5 coordinates. Now when you put those coordinates here, look at the coordinates here. For an example, the red line is basically the function for the half sine x, which is here. The blue line is the regular one, is the original y equal to sine x. Now, so once you have those points plotted, you can just draw a smooth sine graph, because you know how the sine graph will look like.
You are not taking all the points, right? It's impossible to take all the points, but when you take a lot of points, you can guess the graph. But in general, we know that that's how the sine graph will look like. So that's why we are not taking that many points. We will be taking only 5 points, which are the key points, and those will give you the idea that how the period will be completed, meaning how long the period will be. Just in general here, for an example, we know that the period is 2 pi, but that's not true for every sine function. We'll see some variations there too. It's not like that all the sine function will be completing by, after 2 pi. It depends. So we are going to more generic version, but before that we are just trying to show you all the different variations you can have based on how the function is written. For an example here, look at this. Again, in every single graph, you will see that the blue one is the original one. Original y equal to sine x. Okay? And in the red one, we are just trying to show you that how the graph is varying based on some changes in the function. Okay? Now for an example, if you look at the left one, we know that we can all plot it, but without even plotting, you can guess the graph. For an example, left one, here, the red one, in the left side, what is happening? Look at this. You are first multiplying it by 2. So by that, you know that it will be stretched, right? 2 times. So look at this. It's stretched, right? 2 times. How do you know it is stretched 2 times? Look at the peak here. This is the peak point, right? Or the maximum point. Where it is? 1. Look at the peak point here. Look at the minimum point here. It's -1, right? Look at the minimum point here. You see that is stretched 2 times because their peak points, or I'm saying the maximum or minimum points, is basically doubled. And also, because of the negative sign, what happens if you have a negative sign in the function? That is basically mirrored, right? So it's the same thing. It's mirrored. So that's why it's something like here and reflected. And here also, same thing is happening. So we are just showing the same one, but you know, all the little bit extended to the right side, and one half cycle to the left side. So you can see how the graph is varying based on little bit change in the function. But it still has all those properties that the periodicity. It still have all of those that after a certain period, all the values will be repeated for sure. But look is a little bit different because of the function is changing. Now, we are going toward a little bit more generic definition of the sine function, that how, just looking at the sine function, how you will know that what kind of graph you will be expecting. Now, first of all, look at the generic function here. This is the generic function of the sine. Look at this. Y equals to capital A sine bx. Look at the capital B and capital A. Those are some kind of those are some coefficients which can be real number, which will be the real numbers. Okay, they can be real number. Now, first of all, the absolute value of A will be the amplitude of your graph. What is the amplitude? Amplitude means the peak value in the positive and negative side. Now let's say if the A is 2, okay, your maximum will be 2, your minimum will be -2. If A is 5, your maximum point will be 5, your minimum point will be -5. In general, in the regular sine x, it's just y equal to sine x, where your A is 1. So that's why your maximum point is in the regular, the original y. And how about the period? Because, you know, as I said, that so far, whatever.
In all of those, the period was 2 pi. But that will not be the case. It may be different based on how the sine function is written. Okay? Now, what will be the period from here? The period is always 2 pi over b. Now, so far, whatever the sine function you have looked at so far, in all of those sine function, your b was 1. Okay, so far. So you'll see some changes after this slide, but that's why
in all of those sine graph, you have seen that the period is 2 pi, but it will be different from now. Let me show you some example here. Look at this. For an example, we can always get those points, right? I'm saying we can always get those 5 key points. X is 0 degree, 90 degree, 180, 270, 360, and for those 5 x's, we can find 5 y's, right? And we can find xy, 5 points, and we can plot the graph. We know that. But instead of going to that route, we can still just tell how the graph will look like just from that, the sine function. Now, for an example here, what is the sine function? 3 sine 2x. Now, looking at that sine function, what is the a here? So that means what? Your peak will be 3. I'm saying the maximum point will be 3, and the minimum point will be negative 3. That's exactly what happened here. Look at this. Maximum point is 3, minimum point is negative 3. Now at the same time, look at this. What is b here? This is b, right? Let me write the original equation. I'm saying the generic equation of sine x. This is the generic equation. This is the generic equation. Now from here, so if we write this, let's see, 3 sine 2x. Now we can directly compare this one, right? And from here we know that absolute value of a is 3, which will be the amplitude. And b is 2 here, right? Since b is 2, what will be the period? Period is always 2 pi by b. 2 pi over b, right? Which is 2 pi over 2 for this function, which is pi. So the period is pi. Look at this. Do you see the period is pi? This cycle is completing within pi. Since the period is pi, you will know that half of the period will be 90 degree. I'm saying the pi is 180. So half of the period will be pi by 2. You see how it is drawn? So you can just, just from these two information, most likely you'll be able to draw the graph. If you know the amplitude and the period, you should be able to draw the graph. Because you will always start from 0 degree, and you know the peak based on the a. Because since a is 3, you know that point will be 3 and this point will be negative 3. And your period will be 0 to 90, 180. So your half will be intersecting at 90, pretty much. Now you see how, so we extended the graph, the same graph here. So interesting is by 2 pi, you see that here right now we have 2 cycles completing, right? In the earlier ones, by 2 pi we only had in the original one, it was only 1 cycle, but now you see there are 2 cycles because the periodicity is changed, but still that is periodic. Still the values will be repeating, but in a different way. But doesn't matter how you write or how you modify the sine function, it will be always periodic. Any question? Okay. So, this is the more generic version. We are going towards absolute generic one. This is the more generic one. Still, we have all those things true, but this is also including the horizontal shift. Okay. Remember, there was horizontal shift and vertical shift, right? Vertical shift is quite simple because the vertical shift is nothing but you just add a constant to the whole function, or subtract a constant to the whole function, and then if you add, that means that you are shifting the graph upward, the subtracting is going downward. So that's quite simple. But the horizontal shift is a little bit tricky because you are adding the constant to the x, not to the whole function. Okay. Now here, look at this generic form. It's more generic, okay, because we are just doing one step at a time. It's more generic right now. So whatever we have talked so far is right. It's still right. So if it's still okay, pi over b is your period. So still those are right. Now what is new here? The new is this.
C over B is basically your horizontal shift, because you see those are coming from here. I'll show you that why it is C over B. It's not only C, why it is C over B. Now, when you calculate the C over B, it may be more than 1 or maybe less than 1. Why? It may be fraction, right? I'm saying, let's say 2 over 3, which is less than 1, right? Because for an example, if the C is 2, let's say in one function C is 2 or B is 3, if C is 2 and B is 3, what happens? C over B is going to be 2 over 3, and which is less than 1, right? If it is less than 1, then you are moving to the left. Look at this. If it is less than, I'm sorry. Oh, we are talking about less than 0. Maybe it's negative, let's say. Let's say C is negative. So that's less than 0. So we are moving left side, and otherwise we are moving to the right. Okay. Now, how the C over B comes to the picture? It's basically come like this. When you are talking Bx minus C, basically, remember the regular function, because the reason I'm trying to show you, because I wanted to make sure that you understand that still we are talking about the same thing, what we have learned, okay? But you want to know that what is added to the x. To do that, you must have to take B as a common factor. If you take B as a common factor, it looks like this, right? So this is exactly what is added or subtracted with the x, not the C. That's how C over B is coming into the. You don't have to understand everything here, but I'm just trying to show you that what is added to the x, or what is subtracted to the x from the x. That is C over B, not only the C. Okay. Okay. Now, from here we know that how the graph will be. In addition to whatever we know so far, we know that what will be the amplitude of the graph. We know that what will be the period of the graph. Those simple. We also know now what will be the horizontal shift based on the sine function you are given. Okay. Now let's see whether we understand this function here. Now let me write that here first. So the function is y equals to 4 times sine twice x minus 2 pi by something. What is that? Pi by 3. Yeah. So let's write the function y equals to 4 sine 2x 2 pi by 3. Now let's identify what are given here. Now what is a? Absolute a. 4, right? Let's compare the function. Remember the generic function. How it look like? A sine bx minus c. That was the generic version, right? Now we compare it. A is 4, so the b is 2, right? This is your b, and this whole thing is the c, right? So the c is 2 pi over 3. Now from here, we can also find what is c over b. We need to know that because that will be the horizontal shift, right? From c over b. So if you do that, this is your 2 pi over 3 divided by 2, it will be pi over 3. Right? So this is going to be your horizontal shape. Now can you tell me, so is this is greater than 0, right? This is larger than 0, right? Because this is not negative. Now from here, which side the graph will be moving? To the right or left? If it is greater than 0, your graph will move to the right by that unit. Look at the graph is where the graph is moving. Do you see that?
The graph should, in general, the sine graph starts from 0, right? But it is starting from pi by 3 because of this. Because of the horizontal shift to the right. Any doubt? And also, this is going to be the amplitude. Maximum will be 4, minimum will be -4. Exactly what you see here. Look at the maximum.
And what will be the period? What is the formula for the period? B over O. 2 pi over B, which is 2 pi over 2, which is pi. So that means your cycle will complete within pi. Look at this. Do you think the cycle is completing within pi? Where the cycle is completing? 4 pi by 3, right? 4 pi by 3. But where the cycle has started? Let's check. Do you see there is pi? Do you see the cycle? Because here the cycle has started, right? And here the cycle has stopped. Because after this point, everything will be repeated again. So that means that's the ending point of the cycle. So if you do the math, that's the ending point, that's the starting point. So the period is pi, which it should be. It should be pi, right? I'm talking about the period. So be careful about that. So it's based on, because you are just like shifting the whole graph to the right, but still all those properties are valid. So look at this. Just from the graph, from the equation, even if you don't have all the points, you will know how the graph. I'm sure that my MATLAB, you'll see the question like this. You'll be given the equation and a couple of different graphs. You have to identify which graph it is. Just like how you identified the function, right? So you were given some function, and based on the function, you have to identify which graph, which one is the graph of that function, because it has horizontal shift, it has some vertical shift, it might have some reflection, right? We have not done any vertical shift yet here. Okay? So far we did almost everything else. So we have not done any vertical shift yet. But the vertical shift is simple, because vertical shift will be something like this. Just to give you an idea, it will be something like this. Because vertical shift is so simple, just you are adding something with the whole equation. Now if it is positive, your graph moves upward. If it is negative, graph moves downward. The reason I mentioned D, because I'm just A, B, C, D, all those are some coefficients, which are some real numbers. They may be 0, except B. You know why B cannot be 0? If the B is 0, there will be no function. I'm saying the function will be a constant function. Do you remember there is some constant function? How they look like? Most of the cases a straight line, but at the same time they are what? They are parallel to either x or y's. Right? Because there is no x, or I'm saying there will be no x. So remember, A or B cannot be 0. C can be 0, D can be 0. Because what happens if A is 0? The function will be converted to y equals to 0, which is a constant line. I'm saying, do you know what is the line for y equals to 0? Have we ever discussed that? What is a y equals to 0? I know that's a straight line, but which straight line? Y equals to 0 is nothing but x-axis itself. Because look at this. On the x-axis, all the points, y equal to 0, right? So that's exactly the line. So y equals to 0 is the equation for x-axis.
And x equals to 0 is the equation for y-axis, because that's just y-axis. We understand that's parallel line, but those are the equation for the axis itself. Okay, you probably forgot to mention that because none of the slide told that, and I forgot. So. Okay, so let's look at let's see whether we. Now here is an example. Let's try this one. I think this one will be more exciting. So what do we have here? Now we have amplitude. We are also given B, so from B we can guess the period. And interestingly, there is a negative sign. What does it mean? It will be reflected, right? At the end, it will be reflected, right? So try this one and try to see whether you can draw this. I wanted some classroom because in most of our classrooms, what happens is there is a whiteboard behind
this. So what happens is I can just draw it over this graph. So I'm a little bit lazy because once I see the axis again, because those are more perfect than my drawing for sure. Alright, so anyone has the answer? I think you cannot tell the answer, but what is the amplitude? 2, right? And what is the period? It's just pi, right? So, and also this will be reflected. So let's draw the original one first, little bit modified with the amplitude and the period, and then we'll reflect it. So the original one will look like it will start from 0. So let's say it's 1, 2 here, -1, -2, because we have to go all the way up to 2. And let's say this is our pi. Oh, this is pi over 2, this is pi, let's say. I just made it a little bit simple so that you can draw it simply. So this should be your peak point, right? Oh, not here. Here, it will be the peak point. And that's the negative peak. So let's see. Let's see we can. So the graph should look like. Now here, amplitude is 2, right? Because our A is 2. Remember, you cannot take the negative A because A has, remember, that is the absolute value of A. So it doesn't matter whether you have a negative sign or not, you are taking the absolute value. So that is still 2. And then, the period is pi because the B over 2 pi, B is 2 here, so the B over 2 pi is still pi. Now, because of the negative sign, the graph will be reflected, right? So let's see whether we reflect that. The graph will be reflected, because of the negative sign.
Any question? My drawing is not perfect, but I think we can understand how the graph will look like, right?
Any question here? Now, we have several practices here, but let's jump on to this one. This will be, I think, you have now the horizontal shift. So let's see whether we can do this. So we have, let's try this one. This is probably more exciting. Let's try this. So what do we have? We have A given here. We are given B and C. So we have A, B, C. Based on those, we should be able to find the amplitude. We should be able to find the period and also the horizontal shift, right? So we have A here, which is half. Let's see whether we can draw the graph. So what is A? Let's see whether we draw.
equation here. So the equation is y equals to half sine of 2x minus pi over 2. So what do you know here? Absolute value of A is half, which is amplitude, which is half. We know that the B is 2, C is negative pi over, let's see, was it negative C? Let's go back just to make sure I keep forgetting this equation. Yeah, so the C is not negative, C is pi by 2. Just to make sure, because if you compare this should be the value of C, because it preceded by a negative. So the C is not negative pi by 2, because based on the C, how the C, your C by B will be different. So one of the interesting thing you should find here is, if this sign is positive, you should assume that this is 2 negative, right? Because it's minus minus something, right? That means this one minus is for here, and the other minus will be the value of C. For an example, if this is like plus, if this is plus pi by 2, we assume this is basically minus minus pi by 2. So the first minus is this, and this is the value of C. So be careful about that, okay? Since we have the negative sign in the original equation. Now at this point the C is only pi by 2, because we have just one minus sign. Now the C is pi over 2. Now from here we know, what do we know? We know the period is pi by B by 2 over pi, which is again 2 over pi by B, which is that's B is 2 here, right? 2. So that's pi, right? Yeah, B is 2. Okay, and what we know also is C over B, which will be the horizontal shift, is pi by 2 divided by 2, which is pi by 4. The horizontal shift is, now let's do one thing at a time. Now let's do it half. This is 1, and this is negative half. This is 1. Now if we try to, are we doing anything? This one, pi by 4. Yeah, because this pi by 4. Now let's see how we can draw it. So we have vertical shift of pi by 4. So let's plot the graph here. Let's say this is our pi by 4, and this is our pi by 2. This is our pi. Okay. Now cycle is pi, but we still have to go beyond pi, because this is starting from pi by 4. Right. So you did everything in degree instead of radian.
Yeah, you can always do that. But remember, during the test, what happens is, even if you do all the calculations in degrees, make sure you convert it back to pi once you are done. Because the question may look like you will be given this equation and you will be given 4 graphs. And those graphs will be drawn, most of the cases for sure, in radian. They may be even drawn in degree, but as I have seen, those will be drawn in radian. That's the traditional way of drawing. But if someone draws in degree, it's still right. But there is no way, because there is nothing wrong with that. But since in case of the multiple choice question, you cannot change the answer format.
So even if you do in the, so pi by 4 is nothing but 45 degrees. So let's take one more point here, which is let's say this is pi, and then the next point is 5 pi over 4. The reason I did that because I know that the graph will be shifted 45 degree to the right. So the graph should, if the graph starts from 0, it will stop at pi. But now the graph is shifted to the right by 45 degrees, so it will start here, but it will stop beyond 180. More 45 degree more than 180, which will be like 225. This is 225 basically. So now it's up to you. If you want, you can do all those angle in degrees. It's up to you. Now, so think about where the, so if it starts from here, the peak, we know the peak will be half. We know that. But where you will have the half cycle completed? In general, that should be in pi by 2 if it starts from 0, because the cycle is pi. But now it will move further right by 45 degree from 90 degree. This is your 90, right? This is your 90 degree, pi by 2. But since we started after 45, it will be starting from 90 plus 45, which is 135, right? So now what is 135 in pi? That is basically, I think, 3 pi by 4, right? Three pi by 4, right? So at that point, your graph will be intersecting the x-axis and going to the negative side. So let's see whether we can draw it. So we started here. Oops. So maybe let's make it half then. So let's make it larger. So let's see. Let's make it half. Now let's say this is your half and this is your half. Negative peak and positive peak. So everything is as it is, except that we just move it to the right side. So instead of 0 here, this becomes 45. Instead of 90 here, we just move 45 degree further right. And also, instead of ending or stopping the cycle at 180, we moved again 45 degree to the right. And still the peak is half because the amplitude is half. And the cycle is still completing within 180 degree. How do we know? Because if you just subtract the ending point minus starting point, you will still get 180, right? Just subtract 5 pi minus 4 over 4 minus pi over 4. You will see that it is still pi. So that means you are still having the same same cycle. The only thing is it is shifted to the right. Any question, comments? So remember only one point here, because the C, before the C there is a negative sign. So if this is negative something, so the value of C is that value, okay? If this is positive, then the C is negative. Because if this is positive, that means we understand that there is two negative signs. Now let's see whether we can try. So now, with question? Okay. Now let's try some similar graphs for cosine. In cosine, except all the new concepts that we have covered for sine. How the, the cosine is still periodic.
Same periodicity is there, except look at what the 0 is. The 0, sine is 0, right? When the 0 degree, but in 0, cosine is 1.
The cosine is always starting from peak at 0. So that is the only difference in cosine.
So some people call it that the sine and cosine is basically there is a phase shift of 90 degree, because if you move 90 degree left or right, let's say if you start from here or here, sine and cosine will be same. If you start from negative 90 or from positive 90, you'll see that the sine and cosine is same. It's basically the same curve, same kind of periodicity you will feel, that except it starts from, because cosine 0 is 1. You see there in the table at the top, look at the cosine 0. The cosine 0 is 1. So it's basically starting from 0, and cosine 90 is 0. Okay. So, and also you can think this as a period, because we always start the period from here, x-axis in general traditionally, and you will stop the period here after 2 pi, because you see that after 2 pi every points are being repeated. So that's how we complete the cycle. That means that's the period. So that's the time you need to complete the cycle, or that's the degrees you need to complete the cycle. Okay. So 360 degree. After 360 degree, so that's the basic cosine function. Now remember, you can modify or vary the function just like how we did for sine, and based on those modifications, in case of your cosine, things will be changed. I'm saying period will be different, peak will be different, horizontal shift may be there, vertical shift may be included, but after all of these, still there will be periodicity. All the values will be repeated. Maybe shift will be different or period will be different. This is very similar to the sine, except that 90 degree difference. Okay. Now let's look at some variations here. So at this point, look at the function. It's still that is pretty similar. We are writing in this using the same formatting, and here is still the amplitude is A, period is 2 pi by B. Everything is same except it starts at 0, and at 0 that is peak. Okay. For this generic one, the peak is 1, but the peak will be defined by the function. That how the amplitude of what is the amplitude of the cosine function. Okay. Now for an example here, let's say we have a graph here which is -3 cosine pi by 2x. Now first of all, there is a negative sign, so that's why everything will be reflected, right? And the 3 is the amplitude, and you see the peak is 3 and the graph started from 3. It started from 3, but because of the reflection, you see it's starting from the negative sign because of the reflection, because after everything it was reflected. And then also look at the B. B is pi by 2. So what is your period here? So you are basically finding, to know the period, you are doing pi by B by 2 pi. Oh, again, I always just write it in reverse way. So it's 2 pi by B, so which is 2 pi by pi over 2. So that means 4 pi, right? Oh. That's just 4. Interestingly, there is no pi. Pi will be cancelled, right? That's just 4. Now, if you look at the cycle is starting from here, right? If you start from here, you stop here. You see, this is your 0 in the x-axis. This is your 4. So your period is still, because after this point, it will start over from here again, right? So your cycle is completing here, which is 4. Now let's look at some example maybe. But before we go to the example, again, the same equation with C, where C by B is your horizontal shift, just like how we did in sine. And if the C by E is greater than 0, we'll be moving to the right. Smaller than 0, moving to the left. Nothing is different here, same, except the sine. Originally, the sine and cosine shapes are different, and different by the 90 degree phase. Let me see whether we can find. Maybe we can try this one. So here, what do we have? we are given A, we are given B, we are given C. Okay, after this point, we'll also talk about, we'll add the D, which will be the vertical shift. For now, just let's try with A, B, C and see whether we can draw the cosine graph. Nothing is different except the original cosine and sine has a 90-degree phase difference. Alright, so any result? So what is A here is 2 and B is 3, C is 5. Alright, so let's see whether we can. So we are doing the cosine graphs, and here our equation is y equals to 2 cos 3x minus pi. So from here we know that the absolute value of A, which is amplitude, is 2. Right, this is A, this is B, and this is C. B is 3, C is pi, and 2 pi over B, which is period, is 2 pi by 3, and C by B, which is the vertical shift, the horizontal shift, is pi by 3. Okay, now this is what we know so far. Now let's see whether we can draw the graph. So let's start like this first. So the graph here. Now your graph will be starting from pi by 3 because of the horizontal shift, and it will end where? The period is 2 pi by 3, right? And it's starting from pi by 3, so you can do the math like this. You can add those 2 points. This is the starting point, and this is how long the period is going to be. If you add this is going to be pi, right? So the period will stop at pi. So let's draw the pi here. Now this is 60 degree. This is your 90. Now the graph will start from here and the graph will end here, right? Now what is the midpoint? It will be starting at the midpoint, middle of 60 and 180. What is the middle of 60 and 180? 120? Is that 120? Middle of 60. This is the 60, right? And this is 180. What is the middle of midpoint? That's 120, right? Because remember, in the midpoint, the graph, it doesn't intersect at the midpoint. That's the cos. So you start from here. It will intersect after. If you recall from here, let me show you that point. If you recall from original cosine or original cos graph, let me go back. Look at this. What happens? Let's say your period was 2 pi in the original one. What happens? It was intersecting after 90 degree, right? So basically, you were talking about, this is the quarter of the whole thing, whole period. This is the whole twice pi, and this is the quarter of the whole period. Okay, quarter. So after this quarter, you will have an intersection here. So starting from here to here, and from here to again a quarter, there will be an intersection. Now, quarter of the whole period. Now remember, so what is the quarter between these two? What is the quarter? So what is the whole length? This is 60 and this is 180. What is the whole length? 120, right? So what is the quarter of 120? 30 degree, right? That's the quarter. Now, what is this? Is your 60. If you take the 30 degree from here, this is going to be the quarter, right? And what will be the second quarter? This is 90. So that will be 120.
And what will be the third quarter? 150. Because there will be 4 quarters for sure, right?
So this is 60, 90, and 120 and 150, right? Okay, so what is 150? 5 pi over 6, right? That's the 150. Now, if you noticed here, original cosine graph, it intersects at the first quarter, and intersect at the third quarter. It always does that. Okay, so if you notice that, so the graph will be starting from what is the peak for our case? It's 2, right? So let's get the peak here. 1, 2. Let's do it in the negative side. So it will be starting from here, which is the peak, and to start from the peak, it will intersect at the first quarter. Okay, and it will go all the way to the negative peak, which is here, negative peak. It's -2. So it will be going here all the way to the negative peak, and again it intersects at the third quarter. Look at that, first quarter and third quarter. This was the second quarter, right? So every time it intersects at the first quarter and the third quarter with the x-axis. So the first quarter intersection going to the negative peak, second quarter intersection, the third quarter intersection, and again going back to positive peak. Maybe I should draw it a little bit here. So let's say this is our drawing is not great, so we are just trying to make sure that we understand how the graph should look like. This one, if you go further here, what is your question? First quarter, I'm talking about the first quarter. Yeah, not quadrant. I'm talking about the first quarter, because what happens is, whatever the period is, you will divide the period into 4. Let's say our period is starting from 60, it ends at 180. So what is the length of the period? 120, right? So you divide 120 by 4. What do you get? 30. So after every 30, there will be a quarter. So there's the first 30, there's the second 30, there's the third 30, and there's the fourth 30. So if you notice here, every time in the cosine graph intersect the x-axis at the first quarter here, and at the third quarter here, because this is the first, second, third, and fourth. So, and at the same time, we also maintain the peak here, which is 2, and we also maintain the total period, which was 2 pi by 3, because we know that we starting from here, and we added 2 pi by 3 with there, so we know that will stop at pi. And after or before this point, all the points will be repeated, because that's periodic. Remember, the graph is not ending here, so remember the way we draw the graph. Probably we can give an arrow, to be more perfect. We don't need arrow here because everybody knows that's periodic, and it should be going all the way to the infinity. Sine wave never stops unless it's undefined in some points, in some cases, or if it is defined as a piecewise function in some cases. Now, so let's go back to that slide. Now, just one more thing, that how the vertical shift is applied. Remember, I mentioned that the vertical shift can be applied to any of the cosine and sine, and it's nothing just by adding some constant or subtracting some constant.
Now, if you move this kind of vertical constant, what happens? You see here there is a vertical constant added, which is 1. Maybe you can original graph, you can just add a d here. Now, what happens if you do it here? For an example, this is what we have drawn so far. Let's say we add 1 here. Now, what happens? We know that by that 1, your graph will be shifted upward by 1 unit. After you draw it, it will be basically moving upward. So what we can do is, because make it just, let's say we want this as well. So what we can do is we can just adjust the x-axis here for drawing, because we are a little bit lazy. Let's do it here like this. Let's say we move the x-axis down here. That's exactly, because we are shifting the graph upward, so instead of that we just move the x-axis by 1 unit. So that's exactly how it looked like after you add 1 with this. It's not the graph of that function. It's the graph of our function, the one that we just used right now to draw the graph, and I just added 1 with that, and just to make sure we understand what happens. The whole graph would be moving upward by 1 unit. So instead of doing that, I just move the x-axis down by 1 unit. But remember, still, one of the things you might be a little bit confused is how you are calculating the amplitude now. See, amplitude is still from the middle, okay? Because still the amplitude is up to here and here. Remember, the amplitude is not calculated from the x-axis, okay? It was from the middle, so still the amplitude was, whatever the amplitude here was 2. Simply, still the amplitude is 2. Yeah, no. Amplitude cannot be 2 different value, right? It's just 1 value. Yeah, that's the big edge. Because look at this. The amplitude means that your maximum peak will be, for an example here, the amplitude is 2. That means your maximum point will be 2, minimum point will be -2, and that is still true. Before the shifting, it was still true, right? But after the shifting, it was different. But don't try to adjust that. But if you try to adjust that, it will mess up again, because the vertical shift will not be applied in those cases. Okay, so that's probably one of the things. Yeah. So try some of these, and we just have an example here for periodicity. This is a real life example. Nothing except what we did so far. Nothing different. I just wanted to make sure we understand how to do that. We'll not be able to do it probably right now. But just to make sure that we understand this equation, right? That's the generic equation here. So if A is the amplitude, B is used to calculate the period, and also B and C both are required to calculate the horizontal shift, and the D is just the vertical shift here. Now what is given here is the tides are very high in some areas of Canada. The depth of water at the boat dock in Nova Scotia varies from a high tide of 20 feet to a low tide of 6 feet. So this is an important information. High tide is 20 feet, low tide is 6 feet. And on a certain day, high tide at 2 a.m. and low tide is at 8 a.m. So here, these are the times you are given after midnight. So that's the 2 a.m. here, and that's the 8 a.m. probably is here. Okay. Now, if y represents the depth of water in feet, x hours after midnight, use a sine function to model the water depth. So now, first of all, what we need to do is we have to write the sine function. Now, if we can draw the sine function, then the rest is simple. Okay, if you can just write the sine function, I know that if we have the sine function, we can plot it right away. Okay. Now, from the given information, how you can draw the sine function? How do you get the A, B, C, D? You may not have some of those, you may have all of those, but for sure you will have B and C, A and B, but you may not have C or D, or you may have all of those. Any idea? Now look at those high and low tide. From there, can you find the peaks? I'm just giving you some clue. 20 feet and 6 feet. Those are the peaks, right? So let's see, the 20 feet may be the maximum, and the 6 is minimum, right? So the 20 will be here for sure, and the 6 will be somewhere here. So interestingly, your sine curve will be here basically, right? I'm just trying to visualize it. Let's see. The sine curve will be, maybe from 6 to, starting from here, it will be something like this. Now, do you see some kind of vertical shift here? Because the whole graph is here, not on the x-axis, right? Now, what kind of vertical shift do you have? Positive, for sure, right? Now, how much it is shifted? Look at this. It was 6, right? And the maximum was 20. Now, what is the middle of 20 and 6? What is the middle? How much? 14 maybe? Not 14. 13, right? 13 is the middle, right? Between 6 and, because from 6 to 7, 6 add 7, 13, 7 added to 13 is 20. So the 13 is basically, 13 is the amount which is basically vertically shifted. So the D is 13 from there. From the peak, now what is going to be the peak here? See, the peak will still, what is peak? How much is the peak?
Now, you have to think the peak with respect to that line. So the peak will be 7 basically. Because think about the line 13 here. Is 7 and 7, right? So the amplitude is 7. That's how you know that A is 7.
So you got the amplitude, you got the vertical shift. Now, still you are left with the B and C. Now, after what time is coming back to, so how do we adjust that, the B and C? Yeah, because, after, so the only clue you have is 2 a.m. and 8 a.m. These are the only two information you know. So the 2 a.m. is basically lowest, and 8 a.m. is basically peak. Now, how many hours is that? After 6 hours, right? So between low to high is 6 hours. Is basically about 24 hours, the whole peak, whole cycle, right? Because what happens, that from here to here, that's 6 hours. Again, that is 6 hours. Again, that will be 6 hours. So it's basically 4 6 hours, right? Which will be 24 hours. After 24 hours, is it after 24 hours? Because probably if it is at 2 a.m., I'm sure that is 2 p.m. is again repeated. So it's something like 2 a.m., 8 a.m., 2 p.m., 8 p.m. Okay, that's what exactly happening. So think about B and C. I think we are running out of time. So we'll discuss it next class and figure it out that how the C and B can be fixed. But we understand the A and D, right? So we'll think about the B and C and figure it out next class.